This video will look at how to create a rainfall simulation in Tyflow. So the first thing we want to do is we want to create a base plane, which is what the rain is actually going to be interacting and falling down onto and evaporating. So we just want to change the length of that one to something quite large. So let's do about 10,000 by 10,000 as it's the base object. It'll allow for the rainfall to spread across evenly if it does move. Next, we want to actually be adding a tie icon to this. So let's just type in tie icon into the modifier and we can just draw that one out. We want to make that roughly about half the size of what the plane is. We don't want that bigger because otherwise it will come off the actual plane. So change that to about 5,000 each. And then add the gumball tool so you can move that one slightly across. And we want to center that one in the middle and move it along the Z-axis until the arrow is slightly touching the top of the plane there, as you can see. With that done, we can now add the Tyflow modifier and we can create the actual script that is going to be running this rainfall simulation. So let's go into the modifiers, objects, and add the Tyflow modifier there. We can just open up the editor now, and the first thing we want to be adding, we'll make it a little bit smaller first so that we can actually see both screens, so we can see when some of the birth is happening. Add the birth in, and we just want to change the actual amount of particle birth that's going to be happening, which is the amount of rain droplets, to about, not say 100, maybe about 300. And then we go change the amount to about 300 down the bottom there. All right, the next thing we want to be adding is going to be the position icon, which is the tie icon, which is the birth surface for it. And once we click on that one, we just need to click pick and then pick the tie icon. And now you can see there's a cluster of different tiny little spheres on there. Well, not spheres yet, they're small dots because we haven't changed the geometry. Now we can just add in the shape, and the shape itself, we just want to make sure that's below the position icon. If we scroll down and change it to 3D, we can click on sphere, and sphere low res is what we're going to be using today. And then change the display small objects to geometry so that we can actually see those spheres. As you can see, because it's quite a large object, we're going to need to change the scale. So let's just jump that up to about 1,000, and we can see it's a little bit better now. Still a bit too small. Let's jump it up a little bit more and double it to about 2,000. Alright, the next thing we're going to be adding is the physics, so the collision, so make sure it's actually going on a downward trajectory. So add the physics shape into that, and now if we put the slider across, we'll be able to see that it is now falling onto the plane below. But we want to create it so it actually evaporates. At the moment, it's kind of just sitting onto the plane. So now I want to make it delete after time. So we just add the delete modifier now, add that one below physics shape. And at the moment it's on entry, so at the moment none of the spheres are visible, so we want to make sure that it's actually deleting further down the track. Don't want it deleting on entry, so we want to delete it after a little while. So we'll change that to delete by frame. All right, we'll do that one in a second. Let's go back to scale because we want to change the scale because the raindrops are going to be getting smaller and smaller and eventually evaporating, and this will allow for the evaporation. So we'll change that to a relative add. And if we see now, we still can't see it because of the delete on entry. So we want to change that in timing on event entry, and we want to change it to frame. And we change that frame to roughly somewhere along. So we've got, say, 300 frames. Let's do 200 to about 300. There we go. We can start seeing that they're starting to delete now. We wanted them to delete actually as age progresses. So frame might not be the right one that we're going to be using. Something better could be particle age instead. So let's just change that one from frame to particle age. And as we see now, they're starting to slowly evaporate into the surface. So if we go back to scale now, we want to show that the scale of the actual object is changing as it progresses further down, similar to raindrops, and slowly evaporates, and eventually the opacity completely drifts away. So if we change that one to 85, and we jump up the scale again of the spheres, it'll make it a little bit more visible, sorry. So now we can see that it's starting to fade away, but not quite anymore in the sky as it was. So we need to go back to scale. We need to change that one again a little bit further down. So let's try 75 XYZ, and that makes sure it stays uniform. So it's slowly getting there now, but we need to drop it down maybe a tad more. So let's drop it down to 60. There we go. So it starts quite large and eventually evaporates as it hits the surface. And if we go to physics shape, we just want to change the restitution and everything down to 0 because I don't want any friction of really how that water's hitting it. Because realistically, it's basically going to be hitting the surface and it will just be evaporating on impact. So now we can see that in full motion.